Here we have another trig function integrals example problem, and we want to evaluate the following integral: sine 7 of x divided by cosine 4 of x dx. And when we see this type of example problem, we want to think of u substitution as well as trig identities. So we have two different terms, sine of x and cosine of x, and so we can go ahead and use u substitution and evaluate it using two different scenarios. In the first scenario, we'll let u equal sine of x, and in the second scenario, we'll let u equal cosine of x. And we can go ahead and expand this integral out to see which scenario will best fit our u substitution. So we'll go ahead and do that and expand this integral out by taking out a sine of x term. And so we'll look at this sine of x dx, and typically this is our du term when we think of u substitution. And so we can look at our two different scenarios for du, and we can see that the du term in blue has a sine of x term in it, and so we'll use this u substitution, this scenario for u substitution in our example problem. So let's go ahead and use that, but before we do that, we can go ahead and expand our integral a little bit further. So what we see is that in the numerator, we have a sine term, and in the denominator, we have a cosine term, but our u is cosine. And so what we want to do is we want to have our fraction in terms of cosine because we want to do u substitution. So let's go ahead and rewrite this sine 6 of x as sine squared of x cubed, and now we can use a trig identity because we see that the trig identity that links sine squared and cosine squared is here. So we can go ahead and plug in that trig identity, replacing this sine squared of x with 1 minus cosine squared of x. And so now we have our fraction in terms of cosine or in terms of u, and we have our outside of our fraction in terms of du. We can go ahead and do our u substitution by replacing u and du. And the one thing we need to make sure we don't forget is this negative sign and outside of our integral, and that was due to the u substitution that we performed for our du term. The next step is we can go ahead and expand this numerator out, and you can see this is the algebra to do that, but we won't look at that. We'll just look at the simplified version. And so our last step is we can go ahead and take this divided by u to the fourth, and we'll get our following integral. Don't forget the negative sign outside of our integral. And so we can do this integral, very easy to do, and we'll get the following expression, and we can then go ahead and plug our u cosine of x back in for our u and get the solution to our example problem.